This is problem number 2 from chapter 13. It says here that a group opposed to an increase in gas tax claimed that the increase would hurt the working class people the most since they commute the farthest to work. Suppose a group randomly surveyed 24 individuals, asked them for their daily one-way commuting mileage. And here are the results. They want us to use a 5% significance level to test the hypothesis that the three mean commuting mileages are the same. So this is a hypothesis test, and so we want to start off with null hypothesis and an alternative hypothesis. And for us, the null hypothesis is comparing the means. The means for the working class is the same as the mean for the middle incomes, which is equal to the mean for the professional wealthy. The alternative hypothesis, to make this not a true statement or an opposite of a true statement, this is a mean. To make this into an opposite of a true statement, all we need is for one of these things to be not equal to each other. So we can say is that at least one mean is not the same. Okay. So the analysis of variance, what it does is analysis of variance takes a look at each of these data sets, and in order to compare the mean, they also compare the variances between the means, among the means. What we're going to do is we're just going to punch this in our calculator and get our results. So let's take a look at that. You would go under Stat, Test, and I'm going to do the up arrow, and near the bottom, or if not the very last one, is the ANOVA. So that's the analysis of variance. Let's select that. Oh, by the way, let me clear this for a minute. Let's take a look at our stats. The first thing we want to do is that we want to input our data into our L1, L2, and L3. In this case, I have three means to compare. In some problems, you'll have more than three. And so you can just fill in appropriate lists for that. Alright, back to our ANOVA, test, ANOVA, and then we want to get our L1 in there, and then the arguments are just going to be the lists that you have with commas in between. So I have L1, L2, and L3. They're represented by these numbers. And if I press enter, I get several values. So this is an F test that they have. Your distribution is going to be the F distribution, and the distribution is based on the degrees of freedom, and the first degree of freedom that they have is the degree of freedom for the numerator, and if you scroll down, we have the degree of freedom for the denominator. So the distribution, the F distribution, is denoted by F and then 2, 1. Some important numbers to pull out of this. Your result here is your F critical value, or test statistic, sorry. The test statistic is 9.099, and our p-value, well, let's draw the graph that would be associated with this. This is kind of like the chi-square distribution. It's a right tail test, and we have 9.099 over here, and it turns out that the area over here is your p-value, and the p-value is 0.0014. So there's a few other numbers that may or may not be important. The SS factor is, let's make notes of some of these values. SS factor, sometimes it's called treatment. the sum of squares is equal to 3033.81. The MS factor or treatment is 1516.905. And so if we keep scrolling down, we see the SS error is equal to 3500.896, and the SMS error is 166.709. Another number that may be important is the pooled standard deviation among all these values. And that's equal to 12.911. And so those are the values that we can pull out of the calculator. Now, these values help contribute to find our test statistic. But since our calculator actually computes our test statistic for us, these values are not so necessary anymore. Okay, bottom line, we have our p-value. Our p-value is less than our given significance level at the 5% significance. So that's less than alpha. And so here we can reject the null hypothesis. Reject the null hypothesis, which is saying that those two things are equal. So it seems like the means are not all the same. So this is our conclusion based on our findings. Now, it doesn't say that the working class has more mileage, although if you look at a couple of these numbers, it looks like they might be. So there's further analysis in producing that information. But our hypothesis test, at least for this, is just to check if the three mean commuting mileages are the same, and we've shown that they are not all the same. Alright, so I hope this helps with the homework.